Okay, so the first skill that we need to understand is how you factorize your quadratics. And whenever you have a quadratic in the form ax squared plus bx plus c, you are always going to factorize them into two brackets. And we can see that for all four of these first questions, they are definitely in that form. They might not always use the letter x, but they're definitely in that form. Like the first one, we've got a 1t squared plus 11t plus 28. So our a's, b's, and c's are a 1, 11, 28, and then very similar on the others as well. So we're happy that we've definitely got our quadratics in that form. You also need to be able to identify whether it's a monic quadratic or a non-monic quadratic though. Now that sounds like it's really complicated, but actually it's very, very simple. All that you need to identify is the coefficient of the squared term. And what I mean by that is have a look for where your squared terms are. So in the first one, it's a t squared. In the second one, it's a y squared. In the third one, 2x squared, and in the last one, a 5p squared. So when we're looking at the coefficient, we're just looking at what number is in front of the letter. And we can see on the first one, it looks like there's nothing in front of the t squared, but really it's a 1t squared, which means that it's a monic quadratic. There is a 1 in front of the squared term. That is the coefficient. Very similar on the second one. That is a 1y squared, but the third and fourth ones, we do not have 1s as the coefficient, so they are known as non-monic quadratics. We've got a 2 and a 5, so we're going to factorise those with a slightly different skill. Essentially, the monic ones are a little bit easier. We're going to use the same method all the way throughout on the monic quadratics, and all that we need to do is use our sum and product rule. So all that we actually do here is we look at the other coefficients. We've got an 11, and the constant on the end that we've got there is a 28. And the way that the sum and product rule works is that you need to think of two numbers that add to give you the coefficient of the t term here. So that 11 that we've got, and those same two numbers also need to multiply to give you the constant on the end, the 28. So let's take the 28, let's start with that. And let's just think, right, what are two numbers that multiply to give me 28? Well, of course, we could have 1 and 28. That's a factor pair. We could have 2 and 14. What other factors are there? 4 definitely goes into it. Have to times that by a 7, etc., etc. But what we notice at this point is that the 4 and 7 work quite nicely. Because if you add your 4 and your 7 together, you sum them, you will get the 11. But if you multiply the 4 and the 7 together, you will get the 28. So to factorise our first quadratic, all that we need to do is open up our double bracket. And we know in order to get the t squared when we expand these brackets, we're definitely going to need a t and a t. There's no other way to get a t squared when we multiply two things together. And then the 4 and the 7 go in the brackets with them. And then you just need to check what your signs need to be. Are they both positive? Are they both negative? Or maybe it's a combination of both. But to get a positive 11 and a positive 28, they just both need to be positive. And of course, if you want to double check your answer, if you've got time at the end of the exam, maybe, you can expand this double bracket, because expanding is the inverse of factorising. So if we expand that double bracket, we should indeed get what we started with. So let's check that now. So if we expand this double bracket, I need to do t times t, which is t squared, 4 times by t, which will give me a 4t, t times by 7, which is 7t, and the 4 times 7, which is 28. Collect the like terms together. 4t plus 7t gives me the 11t. And we've got the 28 on the end. And we can see that, yes, definitely, that factorisation is correct. Exactly the same idea with the second one. It's a monic quadratic, so I'm just using the same sum and product rule. So similar to before, let's start with the 36 that we've got on the end. And all that we need to do is think of two numbers that multiply to give us that, but they have to add to give us a minus 15 this time. So there's definitely going to be some sort of negative number in there, maybe even two negative numbers. So first of all, what are two numbers that multiply to give us 36? Well, 1 times 36, but you can't add or subtract those to get a minus 15, so it's not that pair. There's also 2 and 18, which is getting a little bit closer. They will multiply together to give us the 36, but you can't quite add or subtract them to get the minus 15. 4 and 9 is another one that might work, but similar to before, they don't quite add or subtract to give us minus 15. But another pair which will work, though, is using 12 and the number 3. If we make both of those negative, so minus 12, minus 3, times them together, you will get a positive 36, but also minus 12 add minus 3 will give you the minus 15. So same as before, open up your double brackets, definitely need a y in both of them to get the y squared when we expand, and then we said a 12 and a 3 will work. Both of them need to be negative this time though. And again, we could double check it, but it will definitely give us the quadratic that we started with if we were to expand those brackets.